So in this video, we're going to talk about a concept called percent yield, which is just a technique and an equation that we use to determine how efficient or effective a reaction was and how effective we were at performing a chemical experiment or a laboratory experiment. And so the percent yield is just looking at the mass of the actual yield divided by the mass of the theoretical yield times 100. Just kind of explaining this equation. And so the term yield just refers to like what did you produce? What did you yield or develop as a result of the reaction? And so I wanted to take a little bit of time in this obvious second take video here to unpack what those two yields meant. And so the actual yield is always referring to the mass of product. And I know it's against kind of standard practice to define a word with a word, but I just think it does such a great job. The actual yield is the mass of product that actually forms in a chemical reaction. So if we were to calculate the percent yield of a lab that we do in the classroom, the mass that you physically made yourself is the actual yield. What did you do in real life? All right, the theoretical yield is the mass of product that is theoretically to form in a chemical reaction. I always refer to the theoretical yield as the calculated yield. Okay, so everything that we've done in our homework so far in this STOIC unit, when we've written out our work and then calculated the final answer, that's always been determining what we call a theoretical yield. What are we expected to make? And then we compare that to what did we actually make to determine a percentage. It's a really simple example, but it says in a lab, you recover 20 grams of product. So there you actually made 20 grams, but according to your calculations, you were expecting to make 25 grams. Well, not all reactions are perfect. Human error is a very real thing as we start to kind of do these labs and experiments ourselves. So if we have 20 grams that we're actually making when we're supposed to be making 25 grams, all we're doing is determining a percentage of that amount. So we do 20 divided by 25 times 100, and we would say that this particular percent yield is 80%. We were 80% effective in determining or making the amount of product that we were supposed to make. Okay? So when we're calculating a percent yield on a quiz or a test or a homework assignment, we always have to be provided with an actual yield. Okay, so here's our starting point, but down here it says if 68 grams is actually produced, this is the actual yield that we're going to be comparing all of our calculated work to. Right? So we got one example here. It says in a reaction between excess beryllium and 95 grams of hydrochloric acid, or HCl, we're going to produce beryllium chloride, which is BeCl2, and hydrogen gas, which is H2 because it's a diatomic. Okay, so now that we've gotten a good understanding of how to determine chemical reactions with all of the math and the moles to mass conversions, this is a more expectation of what we're going to be getting us towards, being able to develop the reaction and then use the stoichiometry to convert. Okay, so I also want to talk a little bit about this term here because you're going to start to see that crop up a little bit more. We're going to talk about that in our last video. But this term excess means that eventually we'll have a certain small amount of each reactant, and then that makes our reaction stop. Here, what we've got is an excess of beryllium, so I always write XS to stand for excess. That means it's not going to run out. Okay, we're going to have an unlimited supply of that reactant, so only these 95 grams of HCl as a starting point for us. Okay, so we're going to use up all of this, and that's going to determine how much product we actually make. And it says in question number 1, what is the theoretical yield of beryllium chloride? And a theoretical yield is always a mass, so we're solving for X grams of beryllium chloride. Okay, so we've got our starting point, We've got an unlimited supply of that reaction, so the reaction will stop once we use up all of our HCl. We want to know how much beryllium chloride we'll produce. But step number one is to balance this chemical reaction. All right, we can't just determine the reaction and then go right into our work. We need to know what's the ratio of reactant to product formation. Well, I've got 2 chlorines and 2 hydrogens over here. So to balance this reaction, all we need to do is place a 2 in front of the HCl. Okay? And then double check, make sure, yep, everything else is balanced. So now we can use our mass-to-mass stoichiometry to convert HCl to BeCl2. So we're going to start with 95 grams of HCl, writing both the grams and the label for that reactant. And again, we're going to multiply in such a way that we cancel those labels out. And in order to convert reactant to product, we eventually want to get to moles, because we know it's for every 2 moles of HCl, we're going to produce 1 mole of BeCl2. Okay, so the first step here is to use our periodic table, again, to determine the molar mass. So we've got chlorine, 35.45. We've got hydrogen, 1.01. Remember, 2 decimal places. So that means that our molar mass of HCl is going to be 36.46 grams per 1 mole. Now, grams of HCl will cancel. And if we've got moles as our next label, that's got to go in the next denominator. And for every 2 moles of HCl, we're going to produce 1 mole of BeCl2. And then again, we're trying to find a theoretical yield, so we want to convert to grams. So we need a 3-step conversion. And our last step is going to be to cancel moles of BeCl2 by converting that into grams of BeCl2. So for every 1 mole, in order to go to grams, again, we need to use the periodic table. So we've got 1 beryllium, which is 9.01, and we've got 2 chlorines that are each 35.45. So we'll get our calculator out here. Times 2 plus 9.01. And our molar mass of product is 79.91 grams. So now we've got everything set up and all the labels canceled out that will cancel out. And this is going to give us our theoretical yield of beryllium chloride. So we'll crunch the 95 divided by 36.46 divided by 2 times 79.91. And our final answer is 104 grams of BeCl2. Again, this is theoretical. In a perfect paper pencil world where no mistakes can happen, 95 grams of HCl will make exactly 104 grams of BeCl2. Well, somebody performed this reaction, used 95 grams, and only wound up making 68 grams. So what is the percent yield of this particular reaction? We take our actual yield, 68 grams, divide it by our theoretical yield, 104 grams, and then multiply that by 100. 68 divided by 104 times 100, we get 65.4% as the effectiveness or efficiency of this chemical reaction.